Hello, everybody. Welcome back to the next session at the Smart City Lighting Summit. I'd like to welcome our next group of presenters, and please keep in mind you can answer or enter in questions for us to answer at the end of the session on the lower right-hand corner of your conference webinar application. Just go to the lower right-hand side and enter those questions, and we'll answer them at the end of the presentation. But before then, I'd like to welcome our next presenters. We have Leora Radetsky. She's a senior lighting scientist at Design Lights Consortium. We have Levin Knock, who's the senior technical manager at the Design Lights Consortium. And we have Kevin Fitzmaurice, who's the principal of light and smart services at Georgia Power. Thanks, guys.
Thank you, Nick. So speaking of the dark night, in preparing this presentation, we contacted an expert on the subject who assured us that dark nights are crucial to the safety and well-being of many nocturnal animals, such as bats. He said that anyone taking this subject lightly must be a real joker. Even so, you may be wondering, why should anyone besides Batman care about light pollution? Well, first, there's the cost of paying for light that nobody wants. The International Dark Sky Association estimates that 1/3 of all the outdoor lighting in the United States is wasted with unshielded fixtures, costing facility owners over $3 billion each year. Besides wasting electricity on unwanted light, other claims of harm include disrupting human sleep patterns, hindering astronomical research, disorienting fish and turtles, plus migratory birds who often fly at night, plus disrupting cycles of predator-prey, sleep, and reproduction for many species, especially insects. This issue is especially relevant to this conference because smart cities often include smart streetlights that can mitigate light pollution when implemented well, or exacerbate light pollution when implemented poorly. As you know, there are many wonderful things about outdoor LED lighting: better color rendering, better uniformity, better aesthetics, and deeper energy savings. This amazing performance is encouraging the proliferation of outdoor lighting. We are lighting up the world, creating the unintended consequence of rapidly growing light pollution. The US National Park Service predicts that at the current rate of increasing light pollution, by 2025, only 3.5 years from now, no dark skies will remain in the continental United States. In this compilation of nighttime satellite images, all of the light that you see that has actually reached a satellite in space is wasted. It's wasting electricity and it's disrupting ecological systems. And actually, this image underestimates the problem because the satellite sensors ignore blue light. This slide will illustrate one of several important cycles that are critical to human civilization that are presently endangered by increasing light pollution. We'll start with people who like to eat. Those same people who like to eat create outdoor lighting. People use outdoor lighting in many ways. This impacts insects that are often attracted to the light and trapped, or else repelled by the light into a smaller living space. Populations of wild pollinators are declining worldwide for multiple reasons, and one big reason is light pollution. Agricultural food production is critically dependent on healthy wild pollinator populations, and people are critically dependent on food that is produced by agriculture that is enabled by pollinators. Personally, eating is one of my favorite things to do. Anybody who likes to eat, or might even miss eating if you ran out of food, is a stakeholder in the need to manage light pollution better than current practice. In our agenda today, first, Leora Radetsky will describe the lighting system attributes and technical performance criteria that mitigate the negative effects of light at night. Next, Kevin Fitzmaurice will describe Georgia Power's approach to lighting at night, including a case study at the Port of Brunswick, Georgia, of an LED retrofit that used network lighting controls to deliver better illumination while at the same time saving electricity plus minimizing the negative effects on nearby coastal wildlife. And I will end with an introduction to DLC's list of LED luminaires and control systems and the new upcoming Luna designation for luminaires that reduce light pollution. And here is Leora.
Slevin. Hi, everyone. I'll be describing the range of lighting attributes and technical performance criteria commonly used to quantify light pollution. To do so, I'll compare the metrics among a dozen organizations who create global standards and rating systems. So let's begin. Some of you are likely aware that in the past year, the IES and IDA announced a strategic collaboration to address light pollution, and their boards adopted the 5 principles for responsible outdoor lighting, shown here. These simple ideas can form the foundation of light pollution standards and guidelines. And in fact, many existing guidelines and standards incorporate at least some of these principles in their technical requirements. These principles have to be quantified, however, because without guardrails, they can be derailed at any time, up to installation and operation. At least 12 organizations worldwide and many additional regulators have introduced standards and guidelines addressing sky glow and light trespass. The 11 organizations covered here range from standard development organizations, or SDOs, like the IES and CIE, to organizations with comprehensive guidelines or rating systems for green buildings or communities, like IWBI, USGBC, Fitwel, and BRE, to community organizations that focus solely on light trespass and light pollution, like IDA, SOLA, the Australasian Dark Sky Alliance, or ADSA, the light pollution expert members of the European Environmental Bureau, or EEB, and Softlights. As you can see here, some organizations like the IES, IDA, and USGBC have multiple standards or guidelines addressing light pollution or light trespass. Other organizations have just one standard or guideline addressing this issue. The reference slide at the end of this presentation includes links to these publications, as well as links to various domestic and international standards and guidelines, regulations that have set thresholds to minimize light pollution. I mentioned earlier that many existing standards or guidelines incorporate these 5 principles for responsible outdoor lighting and link them to a specific technical requirement. It's not difficult to map these principles to specific lighting characteristics, such as distribution, amount, timing, or spectrum. Distribution can be mapped to useful and targeted light. Amount can be mapped to useful, targeted light, and low light levels. Timing to controlled light, and spectrum to color. We can organize and evaluate the standards and guidelines I mentioned earlier using these 4 lighting characteristics. Each of the 4 lighting system attributes can be quantified using various lighting performance metrics. Some of them are familiar to you, but others you may be hearing about for the first time today. Let's begin by talking about distribution. The most common way to differentiate between uplight and downlight and forward and backlight for exterior fixtures is the bug rating system from the IES, which is an acronym for backlight, uplight, and glare. This metric breaks up the lighting distribution into 10 lumen zones, as you can see in the upper left. The threshold criteria is set by lighting zone. A U0 luminaire, for example, has 0 lumens in the uplight zone. The forward light and backlight can also be described using street side versus house side lumens. The graph you see in the upper right is used to describe the coefficient of utilization for each side, so that you can see how efficient a product is at providing light to the street side or house side. Percent uplight is also used in several international standards and rating systems. It's usually specified as a maximum percentage of the uplight from the luminaire directly. The 2 acronyms here are used interchangeably. ULOR is upward light output ratio, and UWLR is upward waste light ratio. The terms fully shielded or full cutoff are sometimes used. Both indicate that no uplight is emitted by the luminaire, but full cutoff also limits the light intensity between 80 and 90 degrees. Fully shielded luminaires do not constrain the light intensity below 90 degrees. The full cutoff term has been deprecated by the IES and is superseded by the bug system I mentioned earlier. The amount of light emitted from the site itself is sometimes constrained as well. Sometimes you'll be provided with a maximum lumen or LPD value to prevent overlighting. In other cases, a maximum illuminance or luminance is given. Timing and controls are a key aspect of controlling light pollution. Often this is quantified with a minimum dimming level. You may be familiar with this from energy codes. Other times, lower illuminance or luminance values are provided post-curfew alongside curfew timing. Sometimes the lights have to be switched off after curfew. In a few cases, control attributes may be given with a range of specificity. Sometimes the use of controls will be indicated without any additional criteria at all. Maximum CCTs are the most common spectral metric used to limit light pollution, although they are a poor substitute for limiting short wavelengths. Without a doubt, we need better metrics to predict how spectrum impacts both light pollution and wildlife. That said, a maximum CCT of 3000 K is fairly common, although lower maximums are now being stipulated. In some guidelines, a maximum percentage of short wavelength is required within a given range. And these vary a lot. For example, in IDA's new innovation category in the Fixture Seal of Approval program, wavelengths between 380 and 520 nanometers may not make up more than 7% of the visible emissions. Finally, some guidelines and standards prefer or require the use of amber light sources to completely omit short wavelengths. This is most often required when the site is adjacent to wildlife habitats, such as sea turtle nesting beaches. In terms of system performance, some standards want some assurance that the light sources are durable and reliable. They may have minimum requirements for lumen maintenance and color shift over time, as well as warranty requirements. If we think about the landscape in the not too distant future, I hope that smart controls will be integrated with other systems to automate when and how much interior and exterior lights will be dimmed, or even switched off in response to environmental occurrences. You've probably heard of some major metropolitan areas switching off their unused office lighting at night to prevent bird collisions during peak migration times. This decision-making could be potentially automated with digital input data. For example, Cornell University has developed software called Birdcast that provides real-time updates on bird migration. If this mapping can be conveyed to a smart lighting system, then the system could be tuned in response. This may not be limited to bird migration data. Automated tuning may be desirable for seasonal mating or birth events in sensitive habitats, or even in response to celestial events like the full moon or a meteor shower. All of the organizations listed on the left propose limitations in order to control sky glow and light trespass, two key attributes of light pollution. They all set limits on the light distribution, the amount, and the timing. Most of these organizations also suggest limits on spectrum to minimize sky glow. In terms of distribution control, the standards use bug ratings, upward light ratios, or the term shielded or fully shielded. U rating thresholds from the bug system are the most commonly used method for limiting uplight. For example, the joint IES-IDA MLO, IDA's Fixture Seal of Approval program, USGBC's LEED version 4.1, IWBI's Well Community Standard, and SOLA's community-friendly lighting program all use U rating thresholds. The second most common method is the limitation on direct uplight from the Luminaire. This is used by CIE, BRE, and members of the EEB. Some organizations use more than one metric to set limits on distribution. For example, ADSA uses the upward light ratio to control uplight, and the bug system very high zones to control high angle light. Fitwell and Softlights are examples of organizations that stipulate fully shielded or shielded luminaires without any threshold metric. There's a lot more variation in the types of metrics or thresholds that are used to control the amount of light to limit sky glow or light trespass. The most commonly used method is a maximum vertical illuminance. This is used by IES and IDA, CIE, EEB, USGBC, and IWBI. Other metrics that are used include a limit on site lumens, or the percent of uplight leaving the site, luminaire lumens, zonal lumens, maximum luminaire luminances or intensities, or limit on sign luminance, or glowing building windows. The most common method of controlling the timing of light in these standards and guidelines is via the use of curfews. Some publications suggest a pre- and post-curfew value, like CIE. Others recommend a minimum dimming percentage to be used after curfew. This is implemented by the IES IDA MLO, LEED version 4.1, and the WELL Community Standard, while others, like the BREEAM International New Construction 2016 standard, suggest that external lighting that isn't used for safety or security should be switched off at night. Organizations such as ASDA, Fitwel, and SOLA require the use of lighting controls, such as motion sensors or smart lighting, but don't stipulate when or how the luminaires are to be dimmed or switched. 8 of the 11 organizations recommend spectral control. The most commonly used metric is CCT, and the range of maximum recommended CCTs ranges from 2200K to 3000K. In some cases, the maximum CCT is paired with a maximum percentage of short wavelength light in a particular range. For example, the low impact lighting standard from EEB states that the maximum luminaire CCT must be 2200K or less, and the energy flux under 500 nanometers must be 6% of the total emitted. If the average light levels are below 5 lux, they allow CCTs between 2200K and 2700K, as long as the energy flux under 500 nanometers is less than 10% of the total emitted. This short wavelength percentage and the range itself also varies between standards. SOLA, for example, specifies that the energy in the 430 to 530 nanometer range must be 25% or less. And in sensitive areas, the energy below 350 nanometers must be 1% or less. I mentioned IDA's FSA innovation criteria earlier with a 7% threshold. They have different spectral requirements in their older 2018 community program guidelines that uses the same 25% threshold as SOLA, but a broader wavelength range that goes up to 550 nanometers. Finally, some standards require the use of amber light for wildlife, or suggest monochromatic light like LPS near astronomical observatories. As you can see in this slide, there is a lot of variation between guidelines, even within the same organization, let alone between organizations. Ideally, we'll begin to see some common thresholds and metrics start to develop as organizations like IES and IDA and the National Park Service begin to work together with their expert members to jointly develop new color metrics and new recommendations. I hope we have a darker future ahead of us. And now, Kevin is up next to talk about Georgia Power's efforts.
Thank you, Laura. I appreciate this opportunity to share what we're doing at Georgia Power as an end user. And this slide deck I'm showing now is referring to the future proofing and interoperability from a utilities perspective. Next slide, please. First, we'll hit quickly on our mission, our vision and mission and guiding principles at Georgia Power. I'm part of the Lighting and Smart Services group at Georgia Power. We want to be the most valued and trusted utility lighting and smart solutions provider. And our mission is to earn customer loyalty by delivering exceptional value through lighting and smart services. At the bottom of the screen, you can see our guiding principles, which we try to stay focused on each and every day. So at the end of the day, we deliver to our customers the services that they need. Next slide, please. What do we do at Georgia Power? Well, we are an investor-owned utility. We're in the state of Georgia in the United States, and we supply electricity to 2.6 million customers over an area of about 60,000 square miles. We own, operate, and maintain about 900,000 outdoor luminaires. Roughly 350,000 of those are on roadways. The other 550,000 are in parking lots and sports venues and shopping centers any type of other off-road application where lighting normally is used. And we also provide smart services in addition to our outdoor lighting. We monitor and control outdoor luminaires wirelessly. We offer video and license plate recognition systems, gunshot detection, environmental monitoring, pedestrian vehicle counting, and small cell 4G, 5G on lighting poles. Next slide, please. What we're doing today, we're in the process of converting over 900,000 luminaires from HID to LED and installing network lighting controllers into each light so that we can monitor and control them remotely. We're monitoring all LED luminaires with a wireless network and a central management system. And we're utilizing digital communication protocols in our LED luminaires and our controllers to be able to accomplish this task. We're using sensors for additional functionality when needed, and we're actively participating on several lighting standards committees. Next slide, please. And we're often asked, why do we use digital communications instead of 0 to 10 protocols and things that are common in North America? We've been using digital communications for 7, 8 years now. They provide a two-way communication method between the LED drivers and the luminaires, the sensors, and the network lighting controllers, the NLCs. We use Dolly, Dolly 2, and D4i. They were selected because they're established lighting protocols. They have published standards and a positive track record. And they provide Georgia Power with what we need. 0 to 10 just would not do what we need. Next slide, please. One of the things about 0 to 10 that I didn't mention on previous slide is it is a one-way form of communication just used for dimming only. And that's why it really would not meet our needs. We're often asked about sensor interfaces. On a luminaire, there's a possibility for us of 2 sensor interfaces, one at the top of the luminaire, which we have on every luminaire. We use a 7-pin receptacle. It's known as ANSI C136.41 receptacle. And we can either put network lighting controllers in on that location. We can also use standard photo controls. And our NLCs are actually registered revenue grade meters, tested to all the standards of a meter on your house. And on the bottom of the fixture, we use the Zaga Book 18 connector, and it allows us to use all different kinds of sensors, anything from motion or presence to environmental and many other types of. So the reason we use these 2 interfaces is they are standardized by ANSI standards. We needed to be locking type for the easy removal and installation of these sensors. And we needed to be able to future-proof our luminaires. And for the bottom of the fixture, we selected the Zaga Book 18 interface for all those reasons above. And that interface is not put into every luminaire, but we do put it in the luminaires when we anticipate the sensors will be needed other than the sensors on top, which are the NLC and photo control. Next slide, please. We sometimes are asked about why we use Zaga and D4i together, and does it meet our needs? And absolutely it does. Again, we're talking about standardized environments for digital communication between our drivers, sensors, and NLCs. And we need devices that are based on standards. This allows Georgia Power to future-proof our luminaires, because as you can see, we're doing more than outdoor lighting. We're doing lighting and smart services. So we need to be able to future-proof these luminaires because it's hard to predict what you'll need in the future. And a key point is it allows for easy installation and removal of sensors. And as I mentioned, it provides a standard framework for manufacturers of drivers, sensors, controllers, and luminaires to use and design and to make their products that we need and other people like us as end users need. Next slide, please. Let's move to a case study of where we apply these different types of features together to provide the customer and again, to be environmentally friendly. We'll focus on the Port of Brunswick, Georgia. As you can see on the left picture, there's a picture of the port. This particular port is not in Savannah, Georgia. It's south of us in Brunswick, Georgia. I'm located in Savannah. This port primarily unloads automobiles, like 4,000 automobiles per ship. And the facility is about 11 miles or so from 10 or 11 miles from Jekyll Island, Georgia, which is a very, it's an area where sea turtle nesting is prevalent, as is on all of the coast of Georgia. But Jekyll Island happens to be a hotbed for the nesting. On Jekyll Island itself, we use 590 nanometer narrowband amber luminaires on that at Jekyll Island itself, because that is right near the nesting. But the Georgia Ports Authority at Colonel's Island, being that we're about 10 or 11 miles away, we are not required or not needed to use narrowband amber at that location. The Ports Authority and the Department of Natural Resources agreed to use white light at that application for safety and security reasons. And we needed to make it work within such a close proximity of Jekyll Island. Next slide, please. What we did there was we installed luminaires made by Cooper Lighting. They're Navion style luminaires. We use Signify sensor ready drivers, D4i, Dolly 2 type drivers. We use Legrand Watt stopper presence sensors, and we use Talenza NLCs to help us transmit and receive data from the Luminaire to our central management systems. The configuration we used here would provide a low lumen output of 30% of full power during nighttime hours, unless there's activity present at the location. The activity could be employees walking, it could be trucks moving, and mostly it's those vehicles, those brand new vehicles being offloaded off the ships and being relocated to staging areas. That activity triggers 100% lumen output until there's 15 minutes of inactivity. And we're talking about 500 lights out here. And so at any given time, probably 400 of them are in the low power mode. If a ship's not being unloaded, they're all in low power mode. What this does is it reduces sky glow by 70% on most nights. When they're unloading a ship, the levels need to be higher for safety and security reasons, but that's very short-lived because as soon as activity dies off, the luminaires go back to 30%. And this assembly provides that low and high lumen output. It also, with the use of the NLCs, we get remote monitoring, we get energy metering, and we get remote operational control when needed. And that energy metering is key because it is accurately measured as a meter on your house would measure. It's revenue grade. And the customer is able to save not just energy, but also the cost of electricity, because we're monitoring how much is actually being used during the, and these are not flat rated because they are able to go up and down in lumen output. So we measure and bill for exactly what is used and only what is used. And the key point here is we reduce sky glow near sea turtle nesting area, and we reduce energy usage. Next slide, please. And that concludes my case study, and I thank you for the opportunity to share.
Thanks, Kevin. And now I'll give an introduction to the DLC and what we're doing about light pollution. The DLC is a nonprofit organization improving energy efficiency, lighting quality, and the human experience in the built environment. We collaborate with electric utilities, energy efficiency programs, manufacturers, lighting designers, building owners, government entities, and others to create rigorous criteria for lighting performance that keeps up with the pace of technology. Together, we're creating solutions for a better future with better lighting. Within the lighting industry, the DLC is best known for its list of over 500,000 solid-state lighting fixtures, lamps, and retrofit kits that all save electricity and qualify for energy efficiency incentives and rebates. This list of lighting products in commercial and industrial spaces is similar to the Energy Star list of lighting products for residential spaces. but Energy Star only covers residential products. For solid-state lighting products for commercial and industrial applications, DLC qualification is required across most of the US and Canada in order to get energy efficiency rebates and incentives in the states and provinces colored here in yellow. In addition, multiple federal building programs use DLC requirements, including the General Services Administration, or GSA, the Department of Defense, or DoD, and the Federal Energy Management Program, or FEMP. The DLC solid-state lighting, or SSL list, averages 1,000 web page hits a day, as you can see in column 2. We also launched a network lighting controls list in 2016, shown in column 3, and launched a horticultural lighting products list for indoor farming applications in 2019. The reason that DLC is relevant in the context of outdoor lighting and light pollution is that we are currently launching a new designation for outdoor LED luminaires that reduce light pollution. DLC is adding our voice to the growing chorus promoting light pollution solutions. We want to do our part in collaboration with others, but we do not claim to have the complete solution. Our new Luna program sets requirements for high-quality outdoor lighting at night, lighting that minimizes light pollution, provides appropriate visibility for people, and limits negative impacts to the environment. In addition to these benefits from appropriate outdoor lighting, energy savings can be achieved by using the right type of light only when and where it is needed. As I mentioned earlier, $3 billion worth of electricity is wasted each year on sky glow. Installation of Luna-compliant outdoor lighting can significantly reduce that waste. We are addressing light pollution as a matter of stewardship because we have the largest lighting product list in the world, and our requirements are reviewed and referenced around the globe. We have enough information to set thresholds and requirements that both save energy and minimize the negative impacts of artificial light at night. With your participation, together, we can make a difference. For Luna, we started with our existing version 5.1 solid-state lighting technical requirements that set minimum thresholds for energy efficiency, chromaticity, and color rendition, as well as lumen maintenance and chromaticity maintenance. The draft Luna technical requirements establish additional performance thresholds, adding to what was already in the SSL requirements, to add performance thresholds for distribution, CCT, and dimming controls for specific DLC categories of outdoor lighting. This way, energy efficiency programs, cities and municipalities, and other lighting decision makers can use Luna to ensure that their product selections will save energy and follow best environmental practices for nighttime lighting. In terms of the metrics for light pollution that Leora mentioned earlier, Luna addresses all of these 4 checkbox columns. For distribution, the U rating from the bug system manages Uplight, with a maximum allowable rating of U2 for some categories and U1 for others. The amount of light is managed by the existing solid-state lighting version 5.1 requirements. For timing, continuous dimming down to at least 20% is required, and for spectrum, CCTs between 2200 and 3000 Kelvin are accepted. We are also working on a research project with Lighting Research Solutions to understand the characteristics of amber lighting and other non-white LED lighting to inform future versions of Luna. This table from the draft Luna requirement shows the types of white light luminaires that can be qualified under the Luna requirements, such as area and roadway, decorative street lights, full cutoff wall packs, bollards, and lighting for hazardous areas. Note that some products that are important for some outdoor lighting projects are not covered, at least not yet in the first release, such as floodlights, replacement lamps and kits, and narrowband non-white lights for astronomers and turtles. When the DLC Luna designation is launched in 2022, it will provide a new opportunity for municipalities and utilities to address light pollution by choosing Luna qualified products for outdoor lighting in the applications covered by Luna, such as bollards, street lights, roadway lighting, and hazardous site lighting. Also, since LED luminaires are likely to remain in the field for 15 to 20 years, the DLC website will enable you to choose products where you can invest a few dollars today in a standardized socket and possibly some more dollars in a digital driver. Then, in 5 or 10 years from now, as your smart city program matures, it'll be relatively easy to add network controls or new types of sensors by plugging new hardware into each socket that you so wisely ordered with the original Luminaire. Standardized sockets and digital drivers will help keep your options open for the future. A simple way to reduce light pollution at moderate cost is to install part night dimming photocontrollers in each ANSI C136.41 socket. That will reduce light trespass and sky glow in the middle of every night when traffic volumes are expected to be low. If your smart city program has funding for network lighting controls, either now or in the future, that will open up several more capabilities, including remotely programmed and adjustable high-end trim and remotely scheduled dimming by the day, week, season, year, migratory events, etc. Cycles of the moon, anything you like. That way, when light is not needed, it is not wasted. And periods when darkness is especially valuable can be prioritized in the schedule. Solutions for light pollution are urgently needed. It's getting worse, and it's very likely to keep getting worse until we all take action together. We can leverage energy efficiency mandates and climate initiatives to address this issue. Whenever LED outdoor lighting is installed to save energy and to help with decarbonization, that's an opportunity to address light pollution at the same time. This is a call to action for everyone in the audience. For instance, there's an abundance of educational material at the International Dark Sky Association website, darksky.org, and the Illuminating Engineering Society, or IES website, ies.org. While research is ongoing, some of this material simply needs better promotion. So that's something to mention and to use in all of your outdoor lighting projects, whether they're in a park or a turtle sanctuary, or a suburb, or even in a downtown area. The Luna technical requirements are currently being developed. A first draft was released for comments in April 2021, and a second draft addressing those comments will be released in mid-September, followed by a 6-week comment period through late October. Anyone is welcome to review the document at designlights.org and submit comments in the Excel comment form by emailing to comments@designlights.org. We plan to release the requirements near the end of 2021, the final version, and to start qualifying products in 2022. If you want to explore further, as Leora mentioned, here are some references that you might be interested in that are in the slide deck PDF. Thank you for your attention, and now we have time for a few questions.
Thanks, Levin. I don't see any questions yet in our chat window, so please feel free to submit your questions at the lower section of your screen. We'd be happy to answer them if we can.
It looks like we got off easy today.
Well, in the absence of questions, I'll give you a question, Kevin. What services are you seeing that people are wanting besides when you mentioned that you're expanding and providing services beyond basic lighting? What are some of those extra features that you're seeing customers want?
Well, you know, we see the smart cities type applications come and go up and down, and as interest levels increase and pilot projects. Unfortunately, we probably have too many pilot projects and not enough true implementations of smart cities. But the word smart cities has a lot of meanings to a lot of different people. So, you know, it can be anything from electric scooters for some people to full-blown network systems. Where we see the most activity, as always has been in the outdoor lighting arena, the remote operational control, you know, through our wireless controllers and monitoring the system. And we're able to provide dimming to our customers who want to use dimming or curfew, because our NLCs are able to meter the usage, so we don't have to flat rate everybody. So people can be flat rated dusk to dawn who want to be, and people who can be metered who want to have a dimming profile. I'll tell you, the activity that we're doing the most these days is small cell deployments on our lighting poles. We have a crew of people that does that every single day, all day, every day. And that's 4G and 5G deployments throughout our cities and counties. That is one of the biggest parts. There's a need, there's a customer, and just like outdoor lighting, it's an established business and it moves forward. We're expecting smart cities opportunities to increase now, but we're in a little bit of a lull. And I'm excited about what the future holds in that area because there's so much promise.
Thanks, Kevin. We did get a question in, Levin, if you would like to answer it. I think you did before, but if you could just clarify again. Joshua Baker asked, is there a public review of the Luna draft available?
So yes, well, yes and no. So we published the first draft in the spring, which I believe is posted on the website, but it's obsolete. So I would suggest if you wait a few weeks until mid-September, then we'll publish the next draft. So the second draft will be coming out in mid-September, a few weeks from now, and then you'll be able to submit comments on that. So yes, there is an obsolete version available at the moment, and there will be the next version available in a few weeks.
Thank you, Levin. All right. There's another question. We were asked if we have a timeline for when we will add criteria for wildlife and ecosystems to Luna. And I will go ahead and answer that. There is no timeline at the moment. This is something that we are dynamically and actively observing. As you could tell from some of my comparisons of the metrics, there's quite a bit of variation in the standards out there. One standards organization I didn't mention is the Florida Fish and Wildlife Commission, who has their own lighting criteria specifically for sea turtles. This competes with a new program from IDA specifically for wildlife that's tuned to sea turtles. And there's actually even another similar program in Australia from the ASDA that also suggests lighting for sea turtles. And they're all slightly different. I think that as we can see from these organizations starting to work together, IDA and IES have a joint MOU to work together to develop new recommendations and a new color metric. IES and the National Park Service also have an MOU to develop new recommendations. As we start to see these stakeholders that have specific expertise, different expertise in lighting systems, in wildlife, in these ecosystems, hopefully we will see standards start to be developed. And then once those standards are available, the DLC will consider incorporating them into future versions of Luna. Okay.
Yeah, it looks like we got all the questions. Everyone, really appreciate you guys coming on and doing the presentation, and thanks for your time.
Thank you.
Thank you.
Thanks very much for having us.
Thank you.